Imagine a small group of early humans trying to survive. One person notices faint tracks, studies the terrain, improves the tool, or recognizes a pattern that everyone else has missed. Another watches the group, reads its mood, builds trust, resolves conflict, and gets everyone moving in the same direction. Neither survives alone. What if different kinds of minds help the same human group survive in different ways? What if our differences were never simply errors or defects, but part of the human survival system? Researchers Helen Taylor, Brice Fernandes, and Sarah Wraight discuss a theory called complementary cognition. The idea is that humans may adapt and evolve through collective cognitive search, differently specialized minds exploring problems, sharing discoveries, and cooperating as a group. Human adaptability may depend partly on the fact that we do not all notice, process, or solve problems in exactly the same way. Different minds may not merely coexist. Together, they may form part of the system that helps humanity survive, learn, and build civilization. The setting changed. The specializations remained recognizable. The person studying tracks may now study data, machinery, biological systems, computer networks, or abstract ideas. The person coordinating the group may now lead a team, teach a class, build community, negotiate conflict, or persuade people to act. Complementary cognition did not disappear when humanity built cities. Those differences came with us. The Bias Amplitude Model, or BAM, is my interpretive framework for examining some of these differences. BAM uses three variables. Bias describes the direction in which attention naturally tends to lean. Amplitude represents the amount of capacity currently available, and load represents the demands being placed upon that capacity. Within the bias spectrum, BAM describes three broad regions: the autistic or analytic neurotype, the generalist bridge, and the social or relational neurotype. These are tendencies across one human spectrum, not three separate species of person. The autistic neurotype often tends toward pattern detection, systemizing, precision, deep focus, design, and conceptual or technical problem solving. The social neurotype often tends toward interpersonal navigation, persuasion, emotional signaling, group cohesion, coordination, and action through relationship. But these are broad tendencies, not rigid boxes. Autistic people can be deeply relational. Socially biased people can be brilliant designers, analysts, and inventors. People overlap, learn, adapt, and express their tendencies differently depending on amplitude, load, health, culture, experience, and environment. To make these tendencies memorable, I use two affectionate archetypes. The autistic or analytic tendency becomes the wizard. The social or relational tendency becomes the knight. The wizard sees the pattern. The knight moves the people. These are archetypes, not diagnoses. They describe recurring cognitive strengths, not everything a person is or everything that a person can do. The wizard may design the system, detect the flaw, test the mechanism, map the pattern, or solve the problem that nobody else could untangle. The knight may explain the idea, build confidence, gather support, organize the group, read the room, and turn possibility into coordinated action. An idea that cannot be communicated may never be adopted. A group without a workable idea may move confidently in the wrong direction. Civilization requires both insight and coordination. Wizards and knights may want the same outcome, while speaking very different cognitive languages. The wizards often communicate through systems, precision, structure, technical detail, and internal models. The knight often communicates through relationship, tone, shared meaning, momentum, persuasion, and social context. One may ask, is the system accurate? The other may ask, will the people trust it? The conflict is often not intelligence. It is not always intention. Sometimes it is translation. Between these broad tendencies are general minds, the GDN, or general distribution neurotype. The GDN may recognize enough of both cognitive languages to connect them. The generalist can translate technical meaning into social meaning, and social needs into practical constraints. This is not merely splitting the difference. The bridge must preserve what matters on both sides, while helping each side understand how the other organizes reality. In the archetypal language of the model, the GDN becomes the steward. The wizard says, I see the pattern. The knight says, I move the people. The steward says, I help them understand each other. The steward translates, coordinates, and carries meaning in both directions. A bridge is not a compromise. A good bridge allows different minds to cooperate without demanding that either one become the other. This is a model of complementarity, not hierarchy. No wizard, steward, or knight is more evolved. None is inherently more intelligent. None is more moral. None is more fully human. And no individual fits perfectly into one pure category. These are tendencies, not boxes. Archetypes, not diagnoses. The purpose is not to rank people. It is to recognize the recurring patterns of strength and misunderstanding so that environments can support cooperation. To be precise, the broader theory of complementary cognition comes from the work of Helen Taylor, Brice Fernandes, and Sarah Wraight. Their theory provides a scholarly framework for considering cognitive specialization, cooperation, and collective search. The AN, GDN, SN spectrum, and the wizard, steward, and knight teaching archetypes are my interpretive contribution through the biased amplitude model. Complementary cognition does not prove the BAM neurotypes or assign fixed prehistoric jobs to different people. It gives us a serious framework for asking how differently specialized minds may work together. But cooperation is not always rewarded equally. Modern institutions often make socially fluent contributions more visible. The person who presents, persuades, networks, and leads publicly may receive immediate recognition. Meanwhile, analytical, sensory, or system-based contributions may remain invisible, poorly translated, or treated as deficit. Some technical environments may reverse that preference, but institutions rarely value every cognitive language equally. So the next question is, what happens when an institution rewards one style of being human more than another? The bias amplitude model was developed by Jeffery Towery. The larger ideas behind the complementary minds, adaptive environments, and cooperative civilization also helped shape my novel, Rise of Atlantis, available through Barnes & Noble. And for a practical look at how complementary cognition can be used in leadership, teamwork, and workplace, see my book, Return to Camelot. I'm not broken because different isn't broken.